Your dryer is designed to fail. A clothes dryer from the 1980s used a thermal cutoff rated for 20,000 cycles. The heating element, motor, and drum bearings were built from steel and copper that lasted 25 years without a service call. A Whirlpool or Maytag from 1985 could run 8,000 loads before the first repair. The machine in your laundry room has a thermal fuse rated for 3,000 to 5,000 cycles. Some models blow at 2,000 cycles. If the new machine is so advanced, why does the fuse fail 4 times faster? And why does it cost $8 to manufacture but $45 to replace? The answer isn't safety, it's revenue. In 2008, the Department of Energy mandated stricter energy efficiency standards for residential dryers. Manufacturers needed to reduce energy consumption per cycle by 15% to maintain Energy Star certification. But you cannot dry a load of towels with less heat in the same amount of time. Physics doesn't care about federal mandates. So the engineers solved the problem the only way they could. They lowered the heating element's maximum temperature and extended the drying time. Instead of blasting your clothes at 160 degrees for 40 minutes, new machines run at 135 degrees for 60 to 70 minutes. Lower heat, longer cycles, same dry clothes. The Energy Star rating stays intact. But here's what nobody tells you. That lower temperature creates a problem. Lint buildup. A dryer running at 160 degrees burns off residual lint particles in the duct. The high heat incinerates the small fibers before they accumulate. A dryer running at 135 degrees does not. The lint sticks to the duct walls, layer after layer, load after load. Polyester and synthetic fibers are the worst. They melt into a sticky coating that traps more lint. Within 3 years, your vent is completely clogged. The airflow drops from 150 cubic feet per minute down to 50. The dryer works harder, the motor heats up, and that's when the thermal fuse is supposed to save you. The thermal fuse is a one-time use safety device. When the dryer overheats past 185 degrees, the fuse melts and cuts power to the heating element. It prevents fires. But here's the scam. Modern thermal fuses are designed to blow not just from dangerous overheating, but from normal wear. A 1980s thermal fuse was rated for the life of the machine. Today's fuses are rated for 3,000 to 5,000 cycles. The average American household does 8 loads of laundry per week. That's 416 loads per year. At 3,000 cycles, your thermal fuse is designed to fail in year 7. At 5,000 cycles, year 12, but most fail sooner. The fuse degrades with each heat cycle. Each time the dryer runs hot, the internal element weakens slightly. Think of it like bending a paper clip back and forth. Eventually it snaps. Appliance repair technicians report thermal fuse for replacements as the #1 service call for dryers. The fuse itself costs $3 to $8 to manufacture. Replacement parts sold to consumers run $35 to $50. A service call runs $150 to $200. And here's what makes it a scam. When the thermal fuse blows, the dryer does not display an error code. It just stops heating. Your clothes tumble, the drum spins, but nothing gets dry. Most people assume the heating element died. They call a repair tech or they replace the entire machine. The thermal fuse is buried behind the rear panel under the drum next to the blower housing. It takes 45 minutes to access. A homeowner with no experience will struggle for 2 hours. And if you install the fuse without cleaning the vent, it will blow again in 6 months. If you're finding this helpful, hit subscribe. I cover the engineering behind everyday scams every week. Now let's talk about what happens when the thermal fuse doesn't work. The National Fire Protection Association reports 13,820 home fires caused by dryers every year in the United States. Those fires cause an average of 7 deaths, 344 injuries, and $233 million in property damage annually. The leading cause is not mechanical failure, it's lint buildup in the vent. The thermal fuse is supposed to prevent this, but the fuse only protects against heating element failure. It does nothing to stop a lint fire in the ductwork. And here's the problem. A clogged vent raises the internal temperature slowly, degree by degree. The dryer runs hotter load after load, but never hot enough to trip the 185-degree fuse. The lint in the duct heats up to 150, then 160, then 170 degrees. It smolders, and then it ignites at around 180 degrees. By the time the thermal fuse detects the temperature spike inside the drum, the fire is already burning inside your wall, consuming the insulation and wooden studs. A dryer fire in a Texas subdivision in 2019 started in the vent duct behind the machine. The thermal fuse never tripped. The homeowner was running a load while at work. The fire burned through the wall into the attic and consumed the entire house in 18 minutes. The fire marshal's report noted heavy lint accumulation in the vent and a thermal fuse still intact. The fuse worked exactly as designed. It protected the heating element. It did not protect the house. But the thermal fuse is just the beginning. The real money is in the sensors. Modern dryers use moisture sensors to detect when clothes are dry. Two metal strips inside the drum measure electrical conductivity across wet fabric. When the moisture level drops, the sensor signals the control board to end the cycle. In theory, this prevents over-drying and saves energy. In practice, the sensors fail constantly. Fabric softener, dryer sheets, and detergent residue coat the sensor strips with a waxy film. The machine can no longer detect moisture accurately. It either shuts off too early, leaving clothes damp and forcing you to run another cycle, or it runs indefinitely, burning energy and wearing out the motor trying to dry already dry clothes. Some sensors fail so badly they read bone-dry towels as soaking wet. The fix is simple. You wipe the sensors with rubbing alcohol every month, but the user manual buries that instruction on page 37 in a section titled Optional Maintenance. Most people never read it. They just replace the dryer. The control boards tell the same story. A 1985 Maytag dryer used a mechanical timer. A small motor advanced a series of cams and switches to control the cycle. When the timer failed after 15 years, the replacement part cost $25. Modern dryers use digital control boards with 8 to 12 sensors, Wi-Fi connectivity, and touchscreen displays. Each sensor is another failure point. And when the control board dies, the replacement costs $180 to $300. Close enough to replacement cost if the machine goes to the curb. Appliance repair data shows dryer lifespans dropped from 18 to 20 years in the 1980s down to 8 to 10 years today. Some models fail within 5 years. The average lifespan of a clothes dryer fell 45% in 2 decades. And here's what ties it all together. The Department of Energy measures energy consumed during operation. That's it. It does not factor in the energy to mine lithium for control boards, manufacture the machine in a factory overseas, ship it across the Pacific on a container ship burning 150 tons of fuel per day, deliver it to your house in a diesel truck, and haul the dead one to a landfill 8 years later. Nobody at the DOE is counting the emissions from the truck that takes your broken dryer to the dump or the coal power plant that smelts the steel for the replacement. The entire life cycle carbon footprint is ignored. A dryer that lasts 20 years is 1 sickle. A dryer that lasts 8 years is 2.5 sickles. 2.5 times the manufacturing, shipping, and landfill tonnage. 2.5 times the carbon emissions, 2.5 times the e-waste. The manufacturers did not fight these regulations. They lobbied for them. Whirlpool, GE, and Samsung sat at the table with the Department of Energy and endorsed stricter efficiency standards, not because they care about the planet, because every new standard produces machines that break sooner. Shorter lifespans mean more replacement sales. Proprietary sensors and control boards mean more repair revenue. And thermal fuses designed to fail mean a steady stream of service calls. A thermal fuse that lasts 25 years generates zero service revenue. A thermal fuse that blows in year 7 generates $150 to $200 per household. Multiply that across 20 million dryers sold per year in the United States. That is not safety. That is planned obsolescence with a Department of Energy certification sticker. Your dryer isn't failing because of bad engineering. It is failing because the engineering is working working exactly as designed. The efficiency mandates created shorter lifespans. The thermal fuses create service revenue. The moisture sensors create early replacements. And the whole system is dressed in sustainability branding that makes you feel guilty for questioning it. If you want to see how the HVAC industry uses the same trick, that video is on screen now.